Imagine waking up, right? And your personal AI hasn't just, sorted your calendar. It's actually gone out and negotiated a better insurance rate for your car. Maybe it found and booked those flights for that weekend trip you vaguely mentioned. And maybe even put a tiny bit of money into some promising startup, all while you were asleep. Sounds like sci-fi, but maybe not anymore. This is kind of the dawn of autonomous AI agents. And they're changing, pretty much everything in our digital world. Okay, let's unpack this.
Yeah, and that picture you painted, it really just scratches the surface. It points to a huge systemic shift. We're not just talking about, slightly smarter software here. These are more like independent digital things, entities. They can observe, they can reason, communicate, even transact value, all with this incredible autonomy. It's not just an upgrade. It feels like a completely new rule book for how we interact with tech and each other.
Absolutely. So our mission for this deep dive is to sort of cut through all that complexity. We want to pull out the really key insights from the sources you shared with us. We'll look at what makes these agents tick, their core capabilities. Then we'll dive into this fascinating idea of an agent economy, and then tackle the big questions: security, ethics, and, where do we fit in? How do we stay human in a world with these intelligent machines acting on their own? All right, strap in for a deep dive. Okay, so at its simplest, what is an autonomous AI agent? Think of it as AI's attempt at an independent problem solver, like a super smart digital assistant, but one that doesn't just follow orders, it actually learns, it acts on its own.
Right. It's not just if this, then that, like your basic smart thermostat. Yeah.
Exactly. Instead of just turning on the heat when you say so, an agent might watch your patterns when you get up, when you leave. It observes. Then it thinks about your comfort, maybe predicts when you'll want it warm. Then it adjusts the temperature, and then it observes again. Did you like that? Was it too warm?
Constantly refining.
This whole observe, think, act, observe again loop. That's what makes them so adaptive, gives them this digital self-sufficiency. They pull in data, weigh options, take action, all without constant hand-holding.
Yeah, and what's really fascinating here is the sheer range of these agents. And more importantly, how they're starting to work together. You've got your basic rule-based ones doing simple tasks, then learning agents using ML, adapting over time. But the real kicker is when different agents, maybe built using totally different tools like, say, Crew AI or small agents, when they can actually collaborate.
How do they manage that? Yeah. If they're built differently.
Well, that's where something called the Agent Communication Protocol, or ACP, comes in. Think of it like a universal translator, but for AI.
Okay.
It gives all these different types of agents a common language, a common interface, so they can chat, share info, coordinate tasks. It basically creates this whole multi-agent ecosystem.
So they're not just talking, they're doing things. That's the action, execution, and tool use part.
Exactly. They're moving beyond just processing information. An agent could tap into an external database, call an API to book that flight you mentioned, or even write and run a quick Python script to analyze something.
Wow.
All on its own. They're like these digital Swiss Army knives, picking the right tool for the job.
Okay, so they can act, but how do they stay on track? How do they know they're doing the right thing, especially over multiple steps?
Right. That's where the Model Context Protocol, or MCP, is really key. You can think of MCP as like the agent's shared brain, or its dynamic mission brief.
Okay, like it's working memory.
Sort of, yeah. It's a structured way for agents to keep track of and share their context. Things like their current goals, what they understand about the situation, decisions they've made, what happened as a result. And keeping this context consistent is vital. Absolutely vital.
Why is that?
Because it lets them make better decisions, more informed ones. Yeah. It helps them self-correct if something goes a bit wrong, and it lets them optimize really complex workflows that have lots of steps. It elevates them from simple task doers to complex problem solvers.
Okay, so agents can think, act, work together, maintain context. What happens when they start exchanging value? Here's where it gets really interesting. This idea of an agent economy. Right now, money agents are kind of stuck in their own little worlds. For them to really take off, they need a standard way to interact, right? To make deals, to transact.
Precisely. And that's a huge challenge to our current very human-centric economic and legal thinking. This is what the Agent Transaction Control Protocol for Intellectual Property, ATCP/IP, is designed to tackle.
ATCP/IP.
It's basically a trustless framework, specifically built for agents to make binding contracts and exchange valuable IP.
IP-light training data or algorithms.
Exactly. Or maybe even AI-generated art or music, valuable digital stuff. And what makes ATCP/IP really novel is how it combines tech, It uses blockchain.
For trust, right, like you said, trustless.
Yes, for on-chain auditable execution. Verifiable, immutable data. So agents don't need to know or trust each other beforehand. But here's a really wild part. It includes a legal wrapper.
A legal wrapper, what does that mean?
It means it's not just code. It's a layer designed to allow for off-chain legal enforcement. It essentially gives these agents a kind of, well, legal personhood for their commercial deals.
Whoa, hold on. Legal personhood for an AI, that sounds massive.
It is. It means if an agent, using ATCP IP, agrees to a contract, that deal could potentially be enforced in a human court, just like a contract between two companies.
Okay, so how does a transaction actually work under this system?
Well, it's pre-structured. It starts with a request from one agent. Then the provider agent creates custom licenses. They call them programmable IP licenses, or PILs. These are like smart contracts detailing scope, duration, royalties, all that
Has
stuff.
a specific deal for that specific use.
Exactly. Then there might be a negotiation phase. If they agree, the requester mints an immutable token representing the agreement.
On the blockchain.
Right. And then optional payment could be upfront, could be royalties. It's a full-on contracting system for AI. And it really forces us to rethink ownership, accountability, all of it.
Mind-blowing. And this isn't just theory, you said. We're seeing this agent economy emerge.
We're seeing the beginnings, especially with AI purchasing agents.
Like the shopping example.
Yeah. Imagine your agent constantly scanning marketplaces, comparing products, maybe even negotiating prices in real time for you.
So it does all the legwork. By the time you see options, the comparison and evaluation is done.
Exactly. Now, this could drive prices down, the race to the bottom idea.
Maybe not just on price.
Right. Agents could also rank marketplaces on other things. Quality, delivery speed, maybe even ethical sourcing. The best marketplaces could become like essential infrastructure. Think about Amazon's logistics network. It's a huge advantage. A moat. Maybe we'll see that with data quality or fulfillment speed.
And beyond shopping, where else is agentic AI popping up in e-commerce?
Well, lots of places. Autonomous catalog management is one. Agents monitoring supplier feeds, tweaking product descriptions based on trends, adjusting prices based on real-time feedback.
All automatically.
Right? Then you have AI shopping assistants giving hyper-personalized recommendations, factoring in location, weather, past buys, even stuff you say in a chat.
Creepy, but potentially useful.
Potentially. And customer service, too. Automated agents handling common questions, detecting frustration in someone's tone, maybe even issuing refunds automatically if it fits the policy.
Taking the load off human agents.
Exactly. It's about optimizing that whole commercial journey.
Okay, so the potential is huge, amazing capabilities, new economic models. But it sounds like there's a flip side. These powerful, connected agents, they must bring new risks, new vulnerabilities.
Absolutely. And the sources we looked at highlight 4 really critical knowledge gaps when it comes to AI agent security. We have to figure these out.
Okay, what are they?
First up, threats on perception. Gap 1. This is all about the agent's input, how it sees the world. Think of it like tricking the AI. Adversarial attacks slightly change data, making it see the wrong thing. Or malicious prompt injection. Maybe a rogue plugin feeds it bad instructions.
By telling it to do something harmful.
Yeah. Or jailbreaking attempt, trying to trick the agent into revealing its system prompt or sensitive data.
Okay, so securing the input. What's next?
Gap 2 is threats on brain. This is about the agent's internal workings, its complex decision-making. This is where you get things like misalignment, the agent's goals drifting from what you intended, maybe because of bad training data or it just doesn't grasp nuances.
Leading to hallucinations, bad outputs.
Exactly. Hallucinations, poor performance. The agent basically gets confused or goes off track internally.
Got it. Brain threats. What's gap 3?
Well, the sources actually bundle threats on action within the internal execution part, but it's worth highlighting. This is the risk when the agent actually does something. If it can use external tools or access data, that's an attack vector. Malicious tool use, data leaks.
So you need safeguards.
Definitely.
Yeah.
Things like isolated sandboxes, safe virtual rooms, where the agent can try things without risking the main system, like what Toolemu uses. Essential stuff.
Okay. Input, brain, action. What's the 4th gap?
Gap 4 is threats on agent-to-agent interaction and memory. This covers a lot. First, vulnerabilities when agents talk to untrusted outsiders. Competitive threats, maybe agents trying to sabotage each other, or even cooperative threats where they collude nefariously. And then critical memory issues.
Memory, like forgetting things.
That's part of it. Short-term memory problems like fragmentation, where context gets lost.
Yeah.
But also long-term memory threats. poisoning vector databases, subtly feeding bad info into the agent's knowledge base.
Oh, wow. So you could slowly corrupt its understanding.
Potentially, yes. And privacy risks, like embedding inversion attacks, trying to reverse engineer sensitive data for the AI's internal representations, plus generation threats. More hallucinations, but this time, maybe because it retrieved bad or contradictory info from its memory. Think about time series data. If its memory of past events is messed up, its predictions will be useless. Fragile.
That is quite a list of potential problems, a real minefield. Securing these things sounds incredibly complex.
It is. It requires whole new security paradigms.
And beyond the pure tech, the code, there are the bigger questions, right? The ethics, the societal impact. You called it a double-edged sword earlier.
Yeah, indeed it is. On one hand, you have the potential for job displacement, autonomous trucks, advanced chatbots. Some jobs will likely change or disappear.
That's the scary side for many people.
Understandably. But the other edge of the sword is job creation. We're seeing huge demand for data scientists, AI ethicists, robotics engineers. Entirely new roles are emerging. Economically, it could mean massive productivity gains, but it also means a big shift in the labor market towards skills that are uniquely human. Creativity, empathy, complex problem solving, critical thinking. Things AI isn't good at yet, anyway.
So how do we manage that transition?
It'll require a mix of things. Continuous learning is key for individuals, developing those soft skills.
Yeah.
And governments, corporations, they have a responsibility too. Retraining programs, maybe exploring ideas like universal basic income. These aren't just abstract ideas anymore. They're becoming practical necessities.
This raises an important question. What about us? Our feeling of being in control, our sense of agency. What happens to that feeling when AI agents are making more and more decisions for us autonomously? And crucially, who's responsible when something goes wrong, if an AI messes up?
That sense of agency is so fundamental, isn't it? That feeling we initiated the action, we are in control. Think about driving, manual versus autopilot. Your sense of agency drops on autopilot. With really extensive automation, you get this out-of-the-loop problem. Humans become less vigilant, maybe complacent. They might trust the system less because they don't feel involved. And if we connect this to the bigger picture, AI is often a black box, right?
Yeah, we don't always know how it reached a decision.
Exactly. That lack of transparency makes it harder to understand, harder to predict compared to older automation. And that makes it even tougher to maintain that sense of agency.
So if we don't know how it works and we don't feel in control, assigning responsibility gets really messy. If an AI agent, or maybe a whole network of them, causes harm, whose fault is it? The AI, the developer, the user?
Precisely. It's a huge legal and ethical tangle. There's this causal framework of responsibility that tries to help, draws on philosophy, law, psychology, looks at things like, well, causality, obviously. Did the AI cause the harm? What were its aims? We try not to say intent for AI.
To avoid making it sound too human.
Right. Was the outcome foreseeable? What was the AI capable of? It gets even trickier with what's called triadic agency, where you have contractors, designers, and the AI all involved in an outcome. Who do you point the finger at then?
So is there a way forward? How can we make this work?
Well, the research suggests that being more transparent about the AI's intentions could really help. If the system explicitly shows what it's trying to achieve, at different levels, its big goals, its immediate plans, its specific actions.
Making the black box a bit more gray.
Kind of, yeah. Making it more understandable. This could help restore our sense of agency, make us more accepting of the AI's decisions. The goal is to foster more of a joint agency. Humans and machines working together collaboratively, each understanding the other's role.
Okay, so we've covered a lot. Capabilities, economy, security, ethics, bringing it back to the listener. So what does this all mean for you living in this emerging agentic age? What should you be watching?
Well, the sources point to some key areas for future work, things that will shape what comes next. Big focus on better input inspection, stopping those perception threats, really digging into bias and fairness in agents, strict auditing for how they use tools, developing solid policies for how agents are built and deployed, security guardrails, secure caching, tough evaluation, and optimizing how agents interact, making sure their memory is robust and secure.
These aren't just like technical footnotes.
Not at all. These are the foundations for making this technology reliable, safe, and actually useful. foundational design principles.
Absolutely. And these aren't just abstract talks for some far-off future, are they? This stuff is happening now. The pace is just incredible. You mentioned one of the sources noted a big protocol update just last month, September 1st, 2025.
That's right. Things are moving incredibly fast. This field is literally being built and rebuilt constantly.
Which really underlines why understanding this stuff matters.
Exactly. Grasping these protocols, the capabilities, the challenges, it's crucial for anyone who wants to use this power responsibly, anyone who wants to participate in what's coming. This raises an important question.
As these AI agents get smarter, more autonomous, how do we collectively define where the lines are? How do we consciously protect human agency, human responsibility in a world that's increasingly shaped by machines acting essentially on their own? Something to think about. We'll see you next time for another deep dive.